assistant is a couple of hours before us, right, Muhammad?
Yeah, right. There are a couple of hours before. Yeah.
So now it's 9 o'clock. My name is Letizia Iaccheri. I am a professor at the Norwegian University of Science and Technology, work in software engineering education for many years. So I'm very happy to be here and to listen to these three presentations, and then we will have a discussion. Our first presenter is Håkon Burden from Chalmers University of Technology. And I give the word to you, Håkon. If you don't see us, we will see you, and we are looking forward to listen to this 5 minutes presentation about your interesting paper. Please, the word is yours, Håkon.
So thank you. And now I have this echo, just like last time.
I will now mute myself, so maybe it will help. And I mute myself, and the floor.
Thank you. I still have the echoes. So if I'm sounding weird, it's because I hear myself with a lag all the time. Anyway, this is work I did with Jan Philipp Steghofer, a colleague of mine, at Chalmers and University of Gothenburg. The challenge, we usually do this introduction of Scrum to our students using Lego. And we bring in a big bunch of Lego and ask the students to collaborate across teams to Lego City together. And since the COVID restrictions, that was very difficult to pull off. So we decided to transfer the game into a digital environment. I can also mention there was 2 different courses. So we've been using the same exercise for 2 different purposes. One is about actually understanding Scrum details and getting a concrete experience before you move into your code project. And in software development methodologies course, it's about a way of doing a process, finding improvement points, and then try out your improvements, so that the exercise fits for 2 purposes. So we shifted to this Minetest environment, which is a free of use version of Minecraft. The challenge was that we also need to shift from a physical to a virtual classroom. So we went to Zoom. We also needed to shift our physical product backlog Scrum boards into a virtual domain, and we chose Trello. Zoom was not something we could choose. We needed to use Zoom because that's Chalmers' educational platform. And due to the breakout room constraints, we could not coordinate ourselves or the students through Zoom. So we also needed Slack as a separate communication channel. And we tried to use Slack. Well, we decided to use Slack because that is what the students often use to coordinate themselves anyway. But some of them use Discord and some of them use Facebook and so on. So it was a challenge, and we'll come back to that. So all these different communication channels and virtual environments created quite a lot of cognitive load, and we saw students just ignoring some of the channels. So we think it's important. Well, there's an possible improvements for setting up better educational virtual environments, but also try to reuse already in place channels to lessen the cognitive load. We also found that it was more difficult to do the sprint reviews in a virtual environment. Also come back to another point that it's very difficult to see what the students are doing. You can see the avatars running around, but you really don't know what the interaction is. And we had some problems with the coordination and the backlog. Either too few have access and then you have a bottleneck, or too many have access and then you have a total chaos because there's no coordination among those who pick user stories or reprioritize in the product backlog. And then we suggest you don't do this on your own, but have a team teacher there or someone who's responsible for tech support. Overall, the students can't make a comparison. They have either done the Lego exercise or the mind test exercise. In both cases, they are overall positive, and they think the challenge is that they don't know everything before they start working on their assignments. As teachers, we think this is a good alternative to Lego when you need to move to a virtual environment. The major drawback is that you lose this observational possibility that you have in a physical classroom of seeing what's going on. And if you look at what literature says, one of the strong points is that you have this inter-team collaboration and you build a shared experience of working agile early in your collaboration with students, and then you use that experience throughout the collaboration when you reflect and do retrospectives and so on. So that's one of the big takeaways. And thank you.
Thank you, Håkon. I think that we can thank you very much, and we go over to the next presentation, and then we will have the discussion after the 3 presentation. So the next presenter is Marco Gutfleisch from Ruhr University in Bochum, and he will present a paper titled "Putting Security on the Table, the Digitalization of Security Tabletop Game and Its Challenges After Taste." So, Marco, please, the floor is yours. Now I unmute myself.
Perfect. Thank you for the introduction. So, I'm a security researcher at Ruhr University Bochum, and also a PhD student as part of the project CASA, which is an excellence cluster founded by the German Research Foundation. So let's start with a short motivation. So basically, we have the idea of like, okay, hey, let's use security games as an icebreaker and educational tool in software development teams. So for that purpose, we wanted to develop a generic study design to evaluate and measure the effectiveness of those game-based interventions. For that, we have like kind of a design which could be used for different kinds of security game-based interventions. So, and at the first start, we wanted to focus on collaborative games, so on like games where people sit around on a table and playing card games or board games or something like that. So, but because of COVID, unlike most teams also work distributed over different locations, we decided that we wanted to conduct this kind of experiment, this first experiment, remotely. So we came up with the idea to digitalize specific tabletop games and card games, so that we could conduct the experiment remotely. So for this first feasibility study, we wanted to investigate the advantages and opportunities of those remotely conducted security game sessions, and also we wanted to explore the challenges and limitations. So is it even possible to do something like that with what we have in practice right now? So what we did, so basically, of course, we had a look what's accessible outside, what's open source, what could we use. And there are a lot of security games out there, but the problem is there are only a few games which are intended to be used in software engineering, or like which could be imagined to be used in the context of teaching developers about security. So we came up at the end with 3 games, which we selected, and we also tried to adapt some game elements in a way that we could push the discussion a little bit, the discussion about security a little bit more forward. So, and we then digitalized those games. We used the open source platform Vassal, which is specifically intended for digitalizing tabletop games and card games. And the game session, within the game session, we used Zoom for audio and video sharing. We used Google Cloud in combination with Vassal to set everything up. And of course, we tried to embed this game session in our study design. And to simplify it here, we used a questionnaire, a standardized questionnaire, where you could measure the developer's security skills. And we asked this at the beginning, so like a couple of weeks ago, before the game session. And we directly asked this after the gaming session to measure short-term effects. And we wanted to ask this also 1 or 2 months later to measure long-term effects. Could this kind of game session really change something? And because our research is coined by like a quality, or our first feasibility experiment is coined by a qualitative question, we only did this with a few participants. We added a focus group that we also could get qualitative insights at the end of the session, so how they felt and what kind of pop-up they had. Okay, what we found. So basically, just 2 highlights here. One thing what we find conducting 5 sessions with 2 different groups was that it was really challenging for the moderator. So the moderator has to have a really deep security knowledge. And also it took us a lot of preparation work to facilitate the session successfully. So it's definitely not the case that you just throw the game into a Scrum team and everything works out. So that is definitely not the case. And also a lot of discussions had to be taken forward by the moderator. And that brings up, I think, to the most important point. And I love this quote because it exactly describes how I felt after those sessions. One participant described that it is not the same as you sit comfortably around a table and drink a beer and play cards and think about your software. And also that it felt that way because it was kind of completely missing nonverbal communication. Really rather short discussions. So the moderator had really to push forward those discussions, and that led to the way that the moderator had a high share of speech, or like mostly the moderator was talking. And it really felt that like there was a lack of communication. So I think the remote setting was really, really challenging here. So to conclude, I would conclude that conducting collaborative security games remotely figured out to be really challenging, and that may be also very challenging in practice. Thank you for listening.
Thank you very much, Marco. Congratulations on your study. Let's go ahead to the third presentation by Paul, and then I'm looking forward to the discussion after then. So Paul, the floor is yours. You will present a paper titled Engineering in a Global Classroom.
Perfect, thank you. Thanks for the introduction. Yeah, welcome to our presentation. In our research, we investigated teaching global projects in a global distributed classroom that are not only challenging from like a software engineering or from a teaching perspective, but also include additional challenges of incorporating hardware such as IoT devices. And while we had to deal with the same hurdles of typical global software courses, including hardware components that students had to develop and deploy to, include the additional challenges of actually making sure on how to set up this distributed hardware deployment. Of course, purchasing this hardware and distributing this hardware to the students and or across the labs that we had at the universities, as well as the increased latency, as well as the challenges of writing integration system tests when creating a software project together with a group of students. The experience report that we've written describes the teaching methodology, the preparation, as well as the conduction of the Joint Advanced Student School 2021, where we offered a 10-day project involving 3 universities and 21 students, which were located across the world in 5 different time zones. So an additional challenge as well, the students were not only located at their university sites or around their university sites, but even further away in China and some other countries as well. The task that we gave the students was to develop a system, a smart city system that consisted of 3 larger subsystems, which included education-focused telodrones controlled using mobile devices that simulated air-based traffic in a smart city environment, Duckybots, which are Raspberry Pi-based model cars that represent autonomous vehicles in our setup, as well as smart lights, which took the place of traffic lights being controllable in a local Wi-Fi network. Yeah, really rounding up the smart city setup that we had. The overall project was divided up into 4 different parts, with the first one being the pre-development preparation, where we created a top-level design of our system and purchased hardware and made sure that we had a few central setups at the universities and used postal services to send some hardware to students or let some students purchase some hardware at home and reimburse them afterwards. We used GitHub as a central source code, as well as knowledge sharing platform. And we used GitHub Actions to enable this continuous integration and delivery workflow to define custom deployment pipelines to directly deploy from the student's home to the hardware environments at our universities. We allocated mixed and diverse groups by asking students for opinions of what they were interested to work on and to make sure that they're really engaged and excited about the topic they want to work on. And after all this preparation was done, we had a project kickoff where I think one of the key learnings that we had, it was really important to enable create a community feeling within the students as they were located across the globe during a pandemic. Everybody was working from home. We used icebreakers as well as interactive introductory courses to make sure that the students get to know each other and that we have a feeling of broadband collaboration and verbalizing and exchanging ideas. After we had the kickoff, we went into the development phase where we used agile methodologies to organize the team's daily schedule and continuously produce shippable product increments after every workday that we had. Every day started with a global meeting at the beginning that involved everybody to enable daily synchronization in terms of status, impediments, and promises, and then followed by meetings in the sub-teams to discuss in depth about what they want to do each day. After that, the students were left for themselves and to decide on their own work schedule and to have meetings and discussions as well as evening events and virtual get-togethers. On the final day, the presentation day, we had final presentations to demonstrate the developed artifacts using remote demos from the labs as well as from the students' homes, and really demonstrating our goal of the course, this continuous integration and delivery workflow from students' home to the hardware development, hardware environment, and showing off their testing as well as the development capabilities. For infrastructure setup, as not all students could have access to hardware and we couldn't send all the hardware to students' home, we had 2 central setups that students could deploy to using their custom build pipelines. One was a Munich-based setup that included some Duckybots as well as places to start and land drones and observe them using live video cameras, as well as a St. Petersburg setup, which you can see here, which has a more sophisticated drone setup as well as many different live cameras that students could use to observe the results of their code being deployed into these remote hardware environments. As already said, we used GitHub Action to make this possible, and we developed a concept we call pair deployment that is described in the publication, enables students to collaboratively work together in this remote setting while interacting with the hardware that they cannot physically interact with at the moment. And of course, at each site, we also had instructors there in case something went wrong. And as you might imagine, as part of such a course, something went wrong here and there with the deployment setup that we had. So in summary, while it was challenging to set up and conduct a course, especially during such a pandemic, and it didn't make life easier with all the different hardware components, we've identified several recommendations as well as a blueprint to conduct similar courses in the future. If you are interested in these types of challenging distributed global software engineering courses. And I'm happy to discuss the results as well as our publication together with you in a few minutes.
Thank you very much, Paul. Congratulations on your study as well. And we have a question already in the chat. It is for Håkon. It is by Kiev Gama. I can read the question myself, or Kiev can unmute and speak for himself. So Kiev, do you want to unmute and ask the question? Okay, I can read the question myself. He writes, I know Lego for Scrum, which fits 4-hour workshop to build a city with Lego with quick sprints to show the concept. How long a project take with this mind test approach?
So it's basically the same. So all we've done is we take the Lego for Scrum sort of framework, but instead of building Lego in 3 to 4 sprints of 15 minutes, we build mind test artifacts in sprints of 3 to 4 hours. But since the Lego for Scrum exercise is much more than just the sprints, you introduce Scrum, you introduce the notion of a backlog, product backlog, you show them the Scrum board, you go through the different roles and responsibilities. You really need something around 3 to 4 hours. And even if you prepare the students in a lecture up front, we found that they don't really make the mapping themselves. So you give them all the theoretical notions about what is a Scrum board, why do we have a Scrum board, what is the role of the product owner, what is the role of the Scrum Master, and so on. And then you put them into this exercise. They don't really connect. So you need to do this again. You need to go through. Here is your Scrum board. Here is your product backlog. Now, who of you is going to be Scrum Master? What is the responsibility of the Scrum Master? So it's not a surprise, really, because having the concrete artifacts in front of you, even whiteboard or Trello doesn't really matter, but having them in front of you, knowing I need to interact with this, just makes it much more real than seeing a PowerPoint presentation about this is what a Scrum board can look like. And this is another example of a Scrum board. They don't make the connection until they actually are in a setting where we say, well, you didn't change the Scrum board, so we can't see that progress. And it's worth taking that time.
Thank you very much, Håkon. There is a question for Paul in the chat by Cesar Franca. If you want to unmute Cesar, you can do it. If not, there is no problem. I will read the question myself. I will read. So the question is for Paul, and it says, besides the local time zones differences, it seems that you didn't have any challenges related to unsync schooler calendar, right? Anyway, how would you deal with it?
Yeah, so I think you're referring to, and I hope I get this question right, to the question like, would different students from different universities have courses or anything else that would block them from participating in that course? And the short answer is like, we deliberately put this course in the semester break of all 3 universities. So and we had the chance to make sure that there's a voluntary course. Students who are interested in that challenge and who are especially gifted as well and could just sign up, and were pre-selected by the participants from all 3 universities. So the students volunteered to have that time in the semester break to participate in the project and try those things out. And therefore, we didn't have big problems of having other lectures or courses within this like 10-day block around Easter, which was kind of good in that sense. And we pre-planned that from like the professor level, I would say, to make sure that we had exactly this time slot which fits all 3 university schedules. Yeah. Otherwise, it would be hard, of course, because you would have to sync up somehow, with classes and everything else. Yeah.
So I have a question for everybody about the COVID impact, because most in what is common to the three papers, that you say, okay, we were doing something and then COVID came and now we are doing something else. So my question that is for you, but also to me as an educator, what will we keep of what we have learned during COVID? Is it possible and it is wishable to go back to a more physical teaching education setting, or will we live always in the future with these new components that COVID forced us to put in place? I don't know who of the three want to start.
I can directly start. I would say, like, from our perspective, I think it is, of course, desirable, especially when dealing with hardware components, to get back into a place where students can actually physically interact with the hardware and solve the problems ideally by themselves, as like this remote setting of like having remote access and having camera feeds and everything else made things difficult but manageable in some way or form. But I would argue that we can take a lot of the learnings that you had while conducting such a course in this online distributed setting can be taken to in-person courses. So, for example, just the fact that we have a heavy focus on this continuous software engineering aspect of making sure that when students develop code, it's actually tested, integrated, and deployed to the hardware environment and doesn't have to be done manually. I think making sure that students still learn from that and apply this in an in-person setting as like a best practice on how to develop software, and which was essential when dealing with like this distributed setting where students couldn't have access to hardware themselves, but like is nevertheless a very important aspect in an in-person setting as well. I think would be one of the aspects that we can definitely take away. And maybe sometimes it's a mixed thing. Some people might be can't travel somewhere, so it would still be an alternative to offer this. But in our course instance, I would say it's desirable to go back in an in-person setting, especially with the differences in collaboration and interaction with hardware components. But I think it's very important that we take some key learnings that we also identified in the experience report and then bring them back into our in-person teaching.
Thank you. It was a very good answer, Paul. Thank you. Do you, Håkon and Marco, have a reflection about this?
Yeah, so at least so for like what we've did here with security games, I think first of all it's highly important that we think about like that not all software teams are working at one place. So like distributed teams, or that at least one or two persons of a team are like distributed and maybe not always in the office. I think that's normal. Like that's how it is in practice quite often. So like having a teaching approach or having like interventions or training educational tools which have that in mind, that we have teams in practice that are distributed. I think that's highly important. But at least what we have feel like using things which are actually used in an in-person event, like card games, where probably you have sometimes a beer on the table, or like tabletop games or something like that. It's quite hard to get this remotely, and I think it's to talk with video is definitely more different and than having a conversation on a real table. So and we also looked at a lot of cybersecurity games. For example, we have a whole industry which is providing cybersecurity games for companies, and they are awesome. Yeah, they have great coding challenges and things like that. But that are things developers do by themselves. Yeah, and maybe they discuss like at lunch or at the coffee break, but that's not something where they're sitting together and talking and discussing about cybersecurity. And that is something I think it's highly important that teams and companies as well as students start discussing about cybersecurity and trying to losing the fear to contact an expert or like to really invest, to really go and talk to people. That was the idea of like testing a game setting to break the ice for communication. So yeah, I think it's difficult, at least from the game perspective. Thank you.
Thank you, Marco. What do you think, Håkon? Will we go back, what is the best we have learned in pandemic that we can bring forward?
So I get the echo again. I think one important thing, and I think this goes beyond just software development, is that we now are so much more comfortable in doing things distributed in virtual environments. And that goes for things, whatever we do, collaboration on canvases or murals and whatever all these tools are called. That has changed, and I think that is something that allows for a lot more different kinds of collaborations than these. We have to travel somewhere to do something together, and everyone has to travel back again. And I think that is an important shift. When it comes to these educational interventions, whatever you want to call them, that we have done, I think the important thing is, at least for me, is to see them as a constructive alignment. So the activity is just a point in a triangle. Then I need to figure out what is the aim of this activity, and how am I going to assess if the activity reaches the aim or not. And then I get a triangle. And then I need to figure out, is this activity suitable for that aim? Can I tweak this activity so it targets the aims? So we use the same exercise in general, but we tweak them a little, specifically in terms of how we want the students to assess the outcome of participation. So when it comes to changing software methodology, the assessment is focused on what is your initial plan, how did you carry it out, what went well, what did not work for you, what will you do next time. So that's a second plan. Carry that out, and how did that work for you? And then you can have a question for all of that. But when we do introduction to Scrum, we can have other questions. So how did the Scrum Master role work for you? Or how did you interact with a product owner? Is that a feasible way of working with a product owner in the future? Or do you want to change anything in how you collaborate with your product owner? Same exercise, same activity, but the aims are different. Define how to improve software methodologies, or learn the basics of Scrum, which of course is going to be reflected in how do we assess being a participant in this exercise.
Thank you very much, Håkon.
And
Thank you.
So virtual or physical, we need to figure out that this triangle works for us.
Thank you. Thank you. So we have a question by Martin Glintz. Again, Martin, if you wish to unmute, we welcome you to speak.
I can try. Do you hear me?
Yes, we hear you very well, Martin. Thank you.
Were the teams all from the same university? Or did you have teams that were composed of students from one university, from the other, and from a third one? And if the latter would be the case, how do you deal with time zone problems then? So as soon as you have a university somewhere in the US, one in China, and one in Europe, you are in deep trouble with respect to synchronous working.
Yeah, I think that's a great question, and thank you. So the short answer regarding the team distribution is that we deliberately chose to have teams where members came from different universities and different backgrounds. So we actually had a questionnaire at the beginning, of course, how they identified from, we ranked them on the skill level as well as the expertise, as well as what they want to work on, and their self-identified gender. And then we tried to make as balanced teams as possible based on this information. And the good thing is that our time difference in our case was over 5 time zones between China and Europe, which was the biggest difference. So China and London, I think, was the biggest time difference that we had. So we tried to have this one synchronization meeting at the beginning UK time, in the morning UK time, which everybody could attend. And then teams tried to self-identify schedules that worked for them. And I think one key element that enabled this was the fact that we used GitHub not only just as a source code repository, but also just to have issues, have a wiki which documents what you're working on, and really made sure that if you work on one part and if you're in earlier time zone and hand something over, it's clearly documented what you're working on. You have a pull request, you have an issue that clearly documents on what you're working on, and really trying to make sure that at the end of each day, the day often ended like in the UK time zone, because it was the last time zone that we had something that was shippable, that built, that we could then demonstrate on the next day, and made sure that this was then handed over, and then we reassigned what we want to work on the next day. But yeah, it was definitely very important. I think also just for creating this community aspect, that we wanted to make sure in this distributed setting that we had this diverse teams, teams from different universities, and then dealing with those time difference issues by one synchronization, and then making sure that the teams could actually then freely plan around their time schedule from that point on.
Yeah, but how would you scale that if you really have time zone problems? So, for example, if you would have US or Canadian universities also, where there is no convenient slot, whatever, where it is not night for one of the students.
Yeah. I would say probably like my first idea would be to have 2 types of synchronization. So some are like a handover workflow, like similar to how IBM did it, like in the 1980s, I would say, with like the follow the sun approach to like hand over parts across the globe, so teams could continuously work on that. Ideally, we would somehow have a handover from like an Asian time zone or to a Europe time zone, and then from Europe to the US, and somehow like have a closed circle around the globe, if that would be possible. That would actually be really interesting to try out. The biggest time zone difference that we had during the pandemic was this one in this course. But yeah, that would be my gut feeling. Or do you have an idea? How would you do? Did you maybe have a course like
No, not really. So I was interested in whether you had any experience with that.
Thank you very much, Martin, for your question and for chatting with us. And I have personally a question. I don't see more questions in the chat, so I ask my question. I work a lot with diversity in computer science. And I hear now Paul mentioning the gender as a dimension for forming groups. So this is very beautiful that you take in that you are aware of this diversity dimension. I wonder if the other presenters want to share anything, if they have any results, any observation about diversity issues, both in related to gender, but maybe also to disability or culture. So how, if you have any insight in how your interventions have worked with respect to diversity dimension. Maybe you can start, Paul, since you mentioned the gender, since you
I think so it, as already said, like it was an important aspect in like the team distribution. It was one of the elements that we had, including like cultural background and of course like association to universities, and then the self-identified gender of the students. And like we've seen this in many other courses at a university, that it is highly beneficial. And I think there's also literature out there that proves that point. So whenever we do team distributions, of course, like in computer science, it's not that easy to get an equal distribution, to be honest, but we'll try our best. And from that, we've seen that these diverse teams have produced great results, and I think it's highly beneficial for the students to better interact with each other in that case, and that's why we incorporated in our decisions on students team distributions, not only in this course but also in other courses, including of course experience level and everything else around this, which are also important factors to create balanced teams. But it's one of the aspects, and I think it's an important aspect that we should be aware of. Yeah.
Thank you. So, what are your reflection, Marco? In the when I approach the security community lately, I understood that the challenges, for example, around the gender balance, can even be bigger than in the software engineering community where I come from. So, yeah, I would like to know your reflection about this.
So maybe like I think as part of the study I conducted here, that was like recruited from we snowballed during recruiting. So that was like we don't had a focus on like splitting up everything like in a diverse context. So but at least what I've experienced here at my university, that there's a trend that it's more, even in the security thing, we're pushing forward to really make this attractive, that it's not only like men who are like in this kind of field. And I think I think that's really impressive that we have a lot of women at our chair, or also a lot of bachelor and master students thesis. I think it's kind of equally split at our chair with supervising security thesis. So this may be a little bit because we have a kind of interdisciplinary approach. So we're doing a lot of empirical research, and we're working with humans and people and stuff like that. But I think I'm not sure how this is in software engineering, but at least I could say what I've seen in security, there's a trend like really pushing a little bit forward, at least at my university and at our chair, that we're trying to.
Beautiful, beautiful. And what about the effect of your game? So when you let subjects play the game, do you observe differences? Have you observed any differences concerning gender or culture or other diversity dimension?
I think that would be a question maybe for a larger context to really put a focus on that and trying to observe, because in our context, like we had teams mixed up of like professionals, which few of them already known each other, and we also have mixed up them with students, with software engineering students as well as security students. So it was even more shocking that things are so complicated when we mix up security students and they still struggle with those games and the contents. So I'm not sure whether I could answer this like as part of this first feasibility study, but I think it would be really interesting to see this in a larger context. Yes. So
Yes.
Yeah.
Very nice, interesting. Håkon, do you have a reflection about this diversity dimension?
There are a lot of things to say. I think for the two different course instances, it's very different student groups. So software improvement methodologies is given to an international bachelor program with far more female students than your average computer engineering program, and a lot of more diverse backgrounds. And that's a struggle in the first year because everybody needs to find a common ground to work from. This course even later in the program, and then you know how to benefit from each other's differences. But it's a struggle in the first year, and quite a few drop out because it's not what they expected, or they want to have a more mathematically heavy engineering education and so on. So not always easy working in diverse classrooms. In the Agile Project Management course, we give that twice a year. And one of the instances is targeting students from business management with an IT specialization and software engineering students from a Swedish bachelor program. So both of them are Swedish speaking, but very different in terms from where you recruit within Sweden. So business management is typically well-educated parents. They come from specific schools with the prestigious names, while software engineering students are much more diverse. Here's where you find the queer students and students that don't want to fit into the norm but do something different. And they also see themselves as programmers, while the business management students see themselves as managers. They are there to be managers. And then we say, well, you have to mix. So every team has to have 2 or 3 business management students and 3 to 4 software engineering students. And they are a bit scared, but it works out really well because not only different skill sets, but also very different mindsets. So some of the software engineering students tend to give the business management students introductions to not programming or coding, but how to set up a complex software engineering project in terms of all the config files and where do you put your database on a server? How do you use local host solutions? And then business management students have taken the same amount of programs, but don't see themselves as programmers. But when they are within the right file, they know how to write source code, but they need help getting there. On the other hand, they are confident in working with external stakeholders. They are eager to work with the notion of minimal product. They really like that it's not so important what the code looks like as delivering value and defining value. And all of them like that this course is very pragmatic. It's a 7-week project. It's perfectly fine to be quick and dirty because you need to get something that an external stakeholder appreciates within that time frame. And all we assess is how did that process work for you? So nothing about did you use the right object-oriented paradigms or patterns? Have you a secure API connection to your database? Is the database schema reasonable and so on? We don't care.
Thank you, Håkon.
Get something working.
Thank you, Håkon. I will go from the database to a more complex question that one of the participants, Ashkan, is asking in the chat. I don't know, Ashkan, if you want to unmute yourself or if you would like me to read the question. So yeah, yes, please, Ashkan, tell us your concern about that you share here in the chat.
Oh, thank you for time. Actually, this is the 3rd time I'm attending ICSE. And do you hear me?
Yes, very well, very well.
Okay. Well, as you all know, we have a very tough friction with U.S. system, and there are some sanctions that is put on Iran. Well, I don't get into political context of why they put sanctions on people that they are not making they do not have the power to create political decisions. But my question is from our scientific community. Well, when I pay for registration, when I attend the conference, when I'm paying for a conference, I would like to have a conference system that is not put restrictions on people who are attending the conference. As simple as connecting to you and using this conference system, I have to use a VPN and I get disconnected. I do not know if it's because of my poor internet connection. I do not know if it's the smart IP detection system that is behind this conference system. But just within the past 20 minutes, I got disconnected maybe 3 times, and I'm currently connected to you by VPN. Basically, we talk about diversity awareness, we talk about open science, but unconsciously, I believe XC and our scientific community, IEEE, we are putting restrictions on Iranian scientists. And see, I myself had a lot of problems with the policies that Iranian government has put, and I spoke openly and I put my concerns and all that. But irrespective of how I view the political system in Iran or how I view the political system in US, I do have a concern that it is very unfair to us in Iran. I mean, even for paying a conference, as we do not have credit cards, I have to pay extra money just to transfer the money for I mean, we do not have financial systems to pay for the $50 for attendance, the $40 I pay for MSR. I had to pay from a very complex and complicated monetary system to pay for the registration. I pay for the registration, then I have all these technical problems just to log in. I'm the chair. I do not.
Sorry.
Yeah, I do
I
not
want
go
to say
on.
that
Just
I
one
want to
more
say
thing.
that I really appreciate your voice, and I can say from my work in diversity that comes very much from the gender part, but during the years I have learned to work at the intersectionality. And for example, in my team here in Norway, many of the female who are in this, if you Google my name, you will see about my project in gender and computer science, and many of the ladies in this groups come from other countries as Norway. They come from Iran, they come from China, and there are the level of diversity that, as you say, can become a not only diversity but sometimes discrimination, can double. So I really appreciate that you speak, that you make us aware. I don't have so much power on the ICSI system, but I will bring your message in conversations, because this intersectionality is very important. We talk about the open science, we talk about the global classroom, and then we have to understand and to listen to concerns like yours, Ashkan. So
I believe in how can I say, scientific diplomacy. I mean, even the political frictions can be lessened, can be worked out if we, at the level of scientists, we talk to each other, and we can. I mean, I have beautiful friends. I have collaborations with all over the world. As a fairness, I would like to know that I'm the head of the department at Shiraz University, and that the percentage of female students attending even cybersecurity, it might be interesting for you, is almost equal to the men. I mean, we have a active women participation in science and in technology. But
I hope you can send me an email later if you Google my name, because I have many female from Iran in my team, and I would like to continue this conversation with you,
Sure.
Ashkan.
Yeah,
So thank you very much.
yeah.
I would like to give
Sorry, I mean, my talk was a bit off, but because you
No.
talked about fairness and diversity, I feel very bad when I see platforms like edX, Coursera, and other things. They also put restrictions for Iranian students to use them. I mean, what do we have to do? I mean, it's not us that making the decisions. It's not us that we have political friction with anybody, but it is us that we are paying the price. And I think even at the higher level, if we can solve these problems at the scientific community, we will have impact, and we will take a very concrete step for world peace. Thank you for giving me the time.
Thank you to you very much. You
Thanks.
really added depth to our conversation, because we cannot talk about the global classroom without ignoring questions like the one you are raising. So I think thank you, and I think you should continue to speak, and I hope to have a follow-up with you.
Sure.
So
I
we
will
have
contact you, Lydia.
Thank you. So we have only a few minutes. If there are no, I don't see more questions in the chat. I would like to give the word back to the speakers, 1 minute each, so that you can just give a last message to us about your work. So we can start from Håkon. Just a small sentence. What shall we remember about your paper when we, as a software engineering educator, we go back to our classes?
Games are fun, but we need to have an objective for using them.
Very good. Very good. So what is your message, Marco?
Well, that was a good message, Hakan. So a little bit more difficult for me. So I think we need more games or more interventions which could be used in distributed context to really counter things like we have in COVID, like that we push forward collaboration and communication in teams.
Thank you. And you, Paul, the last minute, the last message in this session?
I really enjoyed just discussing this with you, and I think it's really important, as everybody did with their publication and their talk, to share your experiences and learn from each other. I think learn from what happened in the pandemic, learn from whatever courses you're conducting, and learn from just the experiences that you can share in such a community, which is really nice to see. And thanks to you also for organizing everything and for managing the discussion today. I think that is also a very important point at the end.
So thank you to all, and thank you to our assistant Mohammed in the background. Everything functioned very well. And to you, Håkon, who are going to take the train, I say god tur. And to everybody, congratulations with your studies, for publishing at ICSE is a big thing. And good luck with your career ahead, and hope to meet you soon. And to the listeners, have a nice ICSE day. Bye all. Bye.
Thank you. See you around.
Thank you. Bye.
Thank you.
Bye.
Hi, Askan. Hi, Askan. Can you hear me?
I can hear you. How are you?
Fine, thank you. I would like to know more about your experience. Maybe we can move to the one of the socialized rooms.
Okay, sure. Or if you want, you can. Sure. I would love to.
Okay. Probably, I'm not sure which is. Let me see which is. Okay, rooms. Yeah, maybe this one, coffee room 2. Coffee room 2.
Coffee room 2. Where can I get in?
you can get in. Oh,
Let me see. Let me see. Exhibitions. I have to go to
no,
exhibitions.
Socialize the last below the exhibitions. There are another option, sponsors, and below.
Oh, socialize. Oh,
Uh-huh.
I see socialize.
Yes, maybe we
Okay.
can choose a small room.
Oh, there is.
Your room.
Okay, coffee room too. That's okay.
Yes,
Sure.
thank you.